Okay, let's move on to some trig. These questions can sometimes be a little bit tricky, but let's just see what we can do. Okay, so it says simplify the following expression to one trigonometric term. Okay, now it's important to remember a couple of things, right? You must remember our cast, right? And remember our co-ratios. Okay. If you're like, oh, I don't know either of those things, please go over your trig notes, guys. These are things that you should be like, yeah, of course, Margie, I remember that stuff. Okay, but let's now see what we can do. First of all, always write out the question, right? I find it like sometimes when I write out the question, sometimes like the way that I should approach it just sort of comes to me while I write it out. So I don't know if that's how it works for you, but just give it a go. Okay, it also helps the examiner know exactly what you're talking about. So, cos 90 minus x. Okay, let's start over here. So we know that we can say sine x over cos x, right? And we know that tan, right? Tan equals sine x over cos x, okay? Which is really handy because that cancels with that. And then that cancels with that. And that whole thing then just becomes 1, which is fantastic. Okay, so we've really simplified that first term. Let's see what we can do over here. Now, this is where this cast comes into consideration. So if we're talking about 180 plus, we're going to be sitting in that tangent over there. I mean, not that tangent, in that quadrant over there where sine is negative. So this is going to become negative sine x. Okay. Now, this is cos 90 minus x, right? And you should know from your co-ratios that that equals sine x. Okay. So now we have negative sine x times sine x, so that becomes negative sine squared x, and you should be able to recognize, right, we know that that equals, I thought we got given that formula, but it appears we don't, right, because we know that 1, let me write it out for you like you know it, so it's 1 equals cos squared x plus sine squared x. Okay, that you should know that formula. I don't think it's given. I thought it was given for some reason, but it isn't. Okay, you should know that, right? So this is just a different form of that. So it equals cos squared x, and that is the one trigonometric term. Fantastic. 5 marks in the bag. Okay, let's now move on to 5.2. Now, it says, without using a calculator, determine the value of. And this is where everyone's like, oh no, we can't use the calculator. Okay, but that's fine, right? Because we can use our formula sheet, right? And our formula sheet gives us lots of things. So, right, we have here sine squared 35 minus cos squared 35. So, let's see whether we have a sine squared minus a cos squared that we can put together. Okay, I see a cos squared minus a sine squared, not a sine squared minus a cos squared, if alpha and beta equal the same thing, right? So let's maybe, oh goodness, bugs for days. Okay, let's maybe transform it so that it is in this form. Okay, I'll show you how we can do that. And then the bottom is 4 sine 10 cos 10. So I'm thinking we should maybe use this over here. Again, it's not exactly right because there's a 4 and that's a 2. But again, we can just manipulate it, okay? Never be scared to just manipulate, okay? I mean, not in real life, but like in maths, that's okay. Don't do that in real life. And nobody likes someone like that. Okay, so let's write this out. Sine squared 35 minus cos squared 35 over 4 sine 10 cos 10. So we're going to manipulate these things to look like the formulas that I pointed out. So here we're going to say negative, then it's going to become cos squared 35, and it's going to become minus now, sine squared 35. And this we're going to say 2, and then 2 sine 10 cos 10. Okay? So now we are looking quite similar, right? So we know here that alpha and beta would both equal 35 in order to be in this case, right? And it makes sense because it's 35 in both these instances. So we can actually just make this negative cos 35 plus 35, right? So I'm basically taking it from this side of the identity to that side of the identity. Sorry, there's like bugs here for days. Okay, and then for the bottom, let's use this identity here. So it's going to become 2, and then it's going to become sine 2 times alpha, which is 10. Okay, so we're getting there, right? So this becomes negative cos 70 over 2 sine 20. Okay, now again, your co-ratios, right? You should be able to identify, right? You can either convert the cos to sine or the sine to cos, whatever tickles your fancy, right? But in this case, I'm just going to make the bottom cos. So it's going to be negative cos 70, right? Over 2 cos 70. Again, it's your co-ratios. When I say co-ratios, I mean this guy up here, okay? I mean this guy up here. So effectively, this sign, what I've said here, is the same as 2 cos 90 minus 20. Okay, that's a co-ratio. You must go and learn your co-ratios, okay? So I've just converted it into this, and then, well, then that's pretty easy. That cancels with that, and the answer is negative a half. Okay, important here to use your formula sheet, guys. With trig, you must always use your formula sheet, and to know your co-ratios and to know this, some of like your very basic trig identities that you're not given. Okay, so we've just done 9 marks worth of trig, right? Let's go and do some more marks. Let's look at 5.3. So it says given, right? You're given that cos 26 equals m. Okay, then it says without using a calculator. Again, students often panic. Don't panic. If they say don't use a calculator, the first thing you should think is, I can use my identities. No problem. Determine 2 sine squared 77 degrees in terms of m. Okay, so let's kind of figure out what we think we could use. I think we could probably, right, use a co-ratio, right? Let's see what we can do, right? Because remember, when we talk about these co-ratios, right, I'm talking about where we're manipulating generally with regard to 90 degrees. So 2 sine squared 77, okay? We could write this as 2 sine 90, right, minus 13. I'm rewriting the same thing, right? So don't be like, oh, she's making up things. She's not. She's just writing it in a different way, okay? So then what we can do, right, is this is a co-ratio, okay, which means that we can write this as 2 cos squared 13, okay? Right, so we have this co-ratio. We have written it out. We've just converted from sine to cos using this co-ratio. It's all squared still, no problem. Okay, but now let's see maybe if we can try write this, because we want to get it, right, in terms of like a 26. So like I'm thinking we maybe want to go over here, right? Because if alpha equals 13 and 2 times alpha equals 26, then we back where m is, right? So we have here 2 cos squared 13. So we kind of like this one, except we don't have this negative one. But we can do this. Add a say negative 1 and then just say plus 1. Because then effectively you haven't changed the sum at all, right? Because negative 1 plus 1 is 0. If you add 0 to a sum, it makes no difference. So then this over here becomes cos 2 times 13 degrees plus 1. Which becomes cos 26 degrees plus 1, which is m plus 1. Okay, so do you see again how important it is for you to know your co-ratios, okay? If you don't know your co-ratios, guys, please just quickly Google them. There are loads of little quick cheat sheets and that sort of thing to help you with your co-ratios. But if you don't know your co-ratios, you're going to struggle with trig, okay? And then obviously try use your identities, okay? 5.3,